Hey friends, welcome to our channel. Let's have a look at the daily challenge problem. Problem 1391. Check if there is a valid path in a grid. So if you look at the problem statement, it might seem not easy for solving this problem. However, this is a standard traversal problem. So here we are going to use depth-based traversal. First, you need to understand the directions, right? So basically, you have a 2D grid, and each cell of the grid represents a street. So here it has some number, let's say 1, which means that it is connecting the left cell and the right cell, right? Similarly for the other numbers. So you are going to start at the upper left cell, that is 0, 0. And then a valid path in the grid is a path that starts from the upper left cell, that is 0, 0, and then ends at the bottom right. So the path should only follow the streets. So notice that you are not allowed to change any street. So we want to return a boolean to check if there is a valid path in the grid. So here in the 3 examples, the first is true. You can do some drawings, and the second is false, and the third one is also false. So because we want to mention that for this problem, for 2 cells, if you want, you can travel from one cell to the other. So you need to be able to travel from the other to the current. So that's why example 3 is returning false. But this is determined. It's determined on the example 3 and its return, right? But I feel that in the problem statement, this point is not very clear. So with that said, basically there are some hints. We're going to use DFS. So the key point for this problem is how to map these numbers into the code. So we are going to do the coding, and in between we are going to explain the logic. First, I'm going to get the number of rows and number of columns. So that is very standard. So you can get grid 0. So next, I'm going to use the following convention. The convention will be the convention. So I'm going to use 0 means up, and 1 means right, and 2 means down, and the 3 means left. So now we can make a map. So directions will be the following. So first 1. So for 1, you can go to left, and you can go to right. So the left will so here let's left will be 3, right? And left will be 3, and the right will be 1, right? So here let's so here 1 is corresponding to 1 and 3. So similarly for 2, you can go up and you can go lower. The up will be 0, and the lower will be down, that is 2. So similarly you can get 3. So I'm not going to do the details for this 2. And 4 is going to be 1, 2. And 5 is going to be 0, 3. Let's see the last one, 6. 6 is right and up. Right and up, 0, 1. So with this map available, so also we want to do the offsets. So first, the offsets is a direction 0, 1, 2, and 3. So here, if you have 0, you are going to go up. So if you go up, the row index is going to downgrade by 1, right? So this is the 1. The 1 is right. So for the right, the column index will be incremented by 1. So the right will be 0, 1. And the 2 is down. So the row index is incremented by 1. And 3 is for left, the row index will be, the column index will be decremented by 1. So now we have this one. So the opposite direction. So here 0 is 2, right? 1 is corresponding to 3, and 2 is corresponding to 0, and 3 corresponding to 1, right? So we have this one now. So next we are going to do the standard DFS. So for this, I'm going to use a set to avoid the repetition. So we have visited, we have a stack. The stack will be, so originally we are at this position, right? So next you are going to see it will be a standard while loop. So while stack, so the current position will be stack pop, right? So then we are going to check if r equals m minus 1 and c equals n minus 1. This means we are at the destination, so we are going to return true. Otherwise, we are going to look at neighbors. So basically, for d in directions, so the current position, so that is grid RC. So we are going to see which cells we can go to or we can connect to. So here first we want to get a DR and DC. So this will be the offset of this the direction, right? So for example, if you are going to do 0 up, so this will be the change in row index and column index. So then the new position, so new R, new C will be R plus DR, C plus DC, right? So then we are going to check if the new position is inbound and not visited. So if 0 is less than or equal to new R less than M, right? And 0 less than or equal to new column index less than N, and this NR and C. Not in visited. So if this is the case, also we need to check. So this is coming from example 3. So we need the next cell shall connect, shall be able to connect back to the current cell. So in other words, from the new position, we should be able to go to the current position. So we need to use this opposite. So here, if opposite D. So here, from D, we are going to go to another position. So if opposite D, so because this is the opposite corresponding to direction, is in directions grid NR NC, right? So in other words, we can from the this position NR and C, we can go back to RC. So if this is the case, so we're going to do visited add. So this basically we put it to the top of the stack. This is the NR and C, and then stack. So here we this is the for add visit. So this is one way, but you can also add here if you can do this. But here we are choosing this one. Now we add to the append NR and C, right? So then if there are available or valid street, so here we should have already returned true. If after the while loop nothing has returned, so we're going to return false. So that's the full logic of this problem. Let's first do a run. Offset. So let's see. Offsets. Visited. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So I would say for this problem, The major part is this map, this several parts, these 3 parts. Then for the DFS, it's rather routine. With that said, I guess that's it for the current video. Thank you for watching.